Good evening. Welcome to Sri Chaitanya Bridge classes. Hello boys and girls, how are you doing? Yeah. Let me see your energy levels here in the chart. Good evening. Adil, Hasini. Yes. Yeah. Okay. So dear students, coming to the point, all of you. So we've been discussing about coordinate geometry, coordinate system introduction we have given, the coordinate system, and especially certain formulae which we frequently use in coordinate geometry like distance formula, section formula. In section formula there are multiple formulae again, finding midpoint of a line segment, points of trisection, finding the ratio in which P divides AB, as well as harmonic conjugates. Then in the yesterday's class we have seen how to find area of a triangle when three vertices are given, how to find the area of a quadrilateral polygon when the consecutive vertices are given. Even we have seen how to find the fourth vertex of a parallelogram and types of a parallelogram, right? Yeah. So what are the best books to build my concepts, right? So basically for math, dear students, so Sri Chaitanya material is a highly, compiled book. You can use Sri Chaitanya material. Apart from this, if you want to go for, reference books and all, there are many almost. Arihant books will be good to understand concepts. Arihant skills in mathematics are definitely good books, and there are many. But for problem practice, you can purely depend on Sri Chaitanya material, well compiled and order wise, difficulty level wise, these are super books. Okay, right? Fine. Today's lecture, dear students, is definitely a very harmonic conjugate is not discussed. Okay, we'll give slide for that also, harmonic conjugates, right? Okay, yes, number is the ruler of the universe. Before I start the lecture, guys, once our slogans: be non-negative, number is the ruler of the universe. Srikar will discuss that point, harmonic conjugate. Okay, in some other class I will include that concept also. All of you please text, guys, let me see all of you here. So be non-negative, number is the ruler of the universe. Number is the ruler of the universe. Yes, thank you. Now all of you are aligned to the class. We shall start, and today's lecture is coordinate geometry itself, but we need to recall certain important points related to geometric points of a triangle. It's a beautiful result oriented class. Result in the sense, you know already in triangles and all, in earlier classes, maybe 6, 7, 8, you might have learnt about centroid, orthocenter, circumcenter, incenter. Let us recall these points and important results which really help us in solving certain problems. Right, dear students? Shall we start? Everyone? Let me see your readiness. Show thumbs up and likes. We shall start. Come on, quick. Ready everyone? Yeah, and if you just observe JEE mains paper, from straight lines, out of many questions, most of the time the questions are linked with geometric points of a triangle. Okay, so all of you focus on this particular class. It is recollection of points from your previous classes as well linked to coordinate geometry. Now you see, dear students, triangle is after all a line segment formed with a closed figure formed with three line segments, but it has wonderful results. So if you ask me to give what is the most beautiful figure, planar figure that can be drawn in a plane, definitely the credit goes to circle, the most handsome figure. After that, after circle, triangle is the figure which has wonderful results, and we are having lot many theorems over it. So we are going to discuss few of some special points related to triangle, especially geometric points or geometric centers I call. You see, dear students, we majorly focus on certain geometric points. One is centroid G. Second one is orthocenter O. In some books it is also denoted by H. O or H, both are okay. The next, circumcenter S. In some books it is also denoted by O. In some books orthocenter denoted by H, circumcenter is denoted by O. Generally we denote here centroid by G, orthocenter O, circumcenter S. Apart from this, incenter I. Incenter I and X centers are also there, I1, I2, I3. Okay. And of course 9-point circle is also there, N. 9-point circle center is N. This is not important, never asked, but we will give major focus on these points, dear students, right? So please text all of you centroid G, orthocenter O, circumcenter S, incenter I. Okay, shall we start, guys? Shall we start? Here I'd like to say many students will have confusion over the terms median, altitude, angular bisector, perpendicular bisector. First, shall we do? Shall we do this? Right, you see. So first point, guys, median in the sense, let me take a triangle ABC, ABC. Median, please try to understand the term median. A median is a line segment joining a vertex to midpoint of opposite side. Midpoint of opposite, please do remember this. So if you join this, this is a median. This is a median. Okay. So what could be this angle? Can anyone say? What is angle AMC? Can I get the answer, dear students? What is angle AMC? Can I get the answer? Quick. What is angle AMC? 90 degrees, 90 degrees, 90 degrees. Yeah, that's why I asked, dear students. So we assume like 90, but need not be 90. Please do remember, it is just a median. Median means this is the midpoint. We know that these two are equal. We cannot say about this angle unless some information is given. 90 degrees is not right answer. Dear students, generally in a particular figure, in a problem, if it is given, since it is like this, some student by default they take like this is 90, which is a wrong notion. Please don't take it like 90. Even median in the sense, this angle need not be 90. This can be any angle, dear students. For example, you take a triangle like this, midpoint is here, this is the median. What could be this angle? Need not be 90. Got my point, everyone? If you draw a median, this angle cannot be commented. Is this clear, everyone? Come on, try to respond. Try to respond, everyone. Yes. After this, guys, then you see in a triangle ABC, let me take triangle ABC, okay. So let me draw median, say this is D, AD is the median. So these two are equal, okay. Now can someone say what is area of triangle ABD, ACD? Can I say that these two triangles will have equal area? Correct or wrong? ADB area and ADC area, are these two equal? I am saying yes or no. These two areas, suppose this area is P, this area is Q, can I say that P is equal to Q? Yes or wrong? You just say true or false or no. No, you are saying fine. Yes or no. You are all saying no. You are all saying no, a few are saying yes, very a few are saying yes. In fact, dear students, may depend on the angle. No, there is no dependency. Let me give the answer. Let me give the answer, students. Yes, they are equal. Yes, please do remember, it is also an important point, because you just drop altitude here. Suppose from A to base you drop altitude, this is height. First triangle area half into base BD into height is H. Even second triangle area half base DC into height is H itself. Here BD is equal to DC, bases are equal, height same, they will have equal area. Got it? Got it everyone? Got it? So a median divides a triangle into two triangles of equal area. Clear? A median divides a triangle into two triangles of equal area. Yes or no? AC need not be equal to ABR. Irrespective of that, these two will have equal area. Okay? This is second point. This is second point, guys. And third point, you see, third point, you take triangle ABC again. You take triangle ABC again. Okay? Now, if you just draw the median one, this is AD is one median, BE is another median. So, two medians will meet. Obviously, the third median will also pass through the same point. So, we can say that all the three medians will be concurrent at a point called, the point of concurrence is called centroid G. The point of concurrence of medians is called centroid G. All of you please text centroid G. Text here centroid G. Medians centroid. You text medians centroid. Medians centroid. Text all of you medians centroid. You see, dear students, the name G is because it is actually center of gravity. Suppose in physics also you will see, if you take a triangular shaped cardboard, if you want to make it stand on the tip of a pen, you have to put the tip of the pen at centroid. That is center of gravity, dear students. So dear students, medians is this. Here one more important point, dear students, one more important point here, one more important point. So here you can see 1, 2, 3, 4, 5, 6. 6 triangles, 6 smaller triangles. All the 6 smaller triangles will have equal area. All the 6 smaller triangles will have equal area. That is a beauty. It's really nice. All the 6 triangles will have equal area. One point. Second point, so suppose in the same figure ABC, suppose G is the centroid, you just join AG, GBC. That means I erased this. These 3 triangles will have equal area. So this question is given many a times in many exams, may not be in JEE, many exams, that so what is that point in the triangle, inside of the triangle, such that AGB, BGC, AGC areas are equal. What is that triangle? Means that triangle is nothing but, guys, that means that point is nothing but centroid. Clear everyone? Clear? Clear? Yeah. And another most important result related to centroid is, centroid divides any median in the ratio 2:1 from the vertex. If this is G, suppose A, B, C, if this is G, suppose D, just G divides, AG is to GD will be 2:1. AG is to GD will be 2:1. Okay. You see, related to median and centroid, I have given so far 5 points. Shall I prove it? Can you bear it? Can you bear the proof? I will give the proof. but array yaar, you are not giving likes and all. So I can prove it. Centroid divides the median in the ratio 2:1. Can I prove it? How many want the proof for this? Let me know, then I will prove it. If you really want to prove the centroid divides any median in the ratio 2:1, how many want? Please let me see in the chart. Come on, quick. Prove it. Prove it. Okay, good. Let me try. You see, dear students, suppose this is triangle ABC. Okay. Right. Suppose this is median. AD is one median. Okay. BE is another median. Okay. So obviously this is centroid G. Okay. My aim is to prove that AG is to GD is 2:1. Let me give in a quick way. Now, you just extend, you just extend GD such a way that AG is equal to GD. I extended this up to say some P. Now you see, dear students, I have taken such that AG is equal to GP. Okay, AG is equal to GP. Okay, if AG is equal to GP, that is fine. So you just join these two guys, even this also. Now you see, this is another median, this is another median. Okay. Now since it is median, DEF is the midpoint. Now midpoint theorem, guys, midpoint theorem. You see, in triangle ABD triangle, see, F is the midpoint of this side, G is the, you see, already I have taken AG is equal to GP, so this is the midpoint. So this is the line segment joining midpoints is parallel to third side and half of it. So this is parallel to this, that means this entire line is parallel to BP. So can I say that GC parallel to BP? GC parallel to BP? In the same way, dear students, in the same way, even here also, you see GE, this is midpoint because it is median, AG is equal to GP, so this is midpoint. So this is parallel to this, correct? This means even this also. So now you see GBPC is a parallelogram because these two are parallel, these two are parallel. In a parallelogram, diagonals bisect each other, bhaiya. Yesterday we have seen. So bisect each other means if this is X, this is also X. Already I have taken GP is equal to AP, so GP must be 2X. Now you tell me G divide this median in the ratio 2:1. Clear? Clear everyone? Got it? Got it? Understand? So just I have extended this such a way that AG is equal to GP. I have formed a parallelogram. So obviously in a parallelogram diagonals bisect each other, we got it. Okay? Right? How many of you like this? Come on, quick. Right, thank you. But I really appreciate the one who asked the proof. That is really interesting. That's very nice to know all these things. That's a good way of learning math. Fine, okay guys. So once again, as far as centroid is concerned, point number 1, the meaning of median. Median means a line segment joining vertex to midpoint of opposite side, first point. Second point, these two triangles are equal, second point. Third point, the point of concurrence of medians is called centroid G. Fourth point, centroid divides any median in the ratio 2:1 internally from the vertex. This is 2. Then fifth point, and centroid is the only point in triangle ABC such that triangle AGB area is equal to GBC is equal to AGC. Clear? And two more points are left, dear students. That is, if you want length of the median, only there is one and only one theorem that helps in geometry. Can anyone say, dear students? Suppose D is the midpoint, length of the median if you want. Suppose AB is given, AC is given, BC is given. You know all the three sides. Can you just tell me a theorem which helps me to find the length of the median? Can anyone in the class? Quick. Can anyone in the class give 1729? Yes, thank you. Now the time is 1729. Lovely students. You are just simply following the class. I appreciate, dear students. Thank you very much. You touched my heart. Okay? Right. Chalo. Yeah. Can you name the theorem? Can you name the theorem? Pythagoras theorem? No. No, not Pythagoras theorem. Here 90 degrees is not there. Arey yaar, it is Apollonius theorem. Please, all of you do remember, in any problem, if you want length of the median, 99% of the cases we will be using Apollonius theorem. Apollonius theorem says, you see, AB square plus AC square. AB square plus AC square is twice either, okay, AD square plus either BD square or CD square. Both are equal. So you can write BD square. This is a very, very important result that you need to remember. So Apollonius theorem, guys, Apollonius theorem to find length of the median, right? Clear? And after these 6 points, the last point that is related to centroid is, guys, with respect to coordinate geometry, if A, B, C vertices are given, A x1 y1, B x2 y2, C x3 y3 vertices are given, how to find the centroid? Centroid is very simple to take. It is centroid is nothing but the average of the 3 points. Average G is nothing but x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Proof is also simple, guys. You see, midpoint is nothing but B plus C by 2. You just find the point which divides AM in the ratio 2:1. You will get A plus B plus C by 3. That's all. Proof is very simple. Proof is very, very simple in fact, right? So midpoint is B plus C by 2. This is A. Find the point which divides this in the ratio 2:1. You are going to get the answer. Right, everyone? Clear? Right? So this is centroid. And generally in problems, you will be asked, you will be given ABC, you can find centroid by this. So just try to remember as a mnemonic, G is nothing but A plus B plus C by 3. So now, sometimes you may be given 2 vertices and centroid third vertex. C is nothing but 3G minus A minus B will be more easy to do. It's very easy. Triple the centroid and subtract A and B. Correct. Correct. Many of you did not like the video. I am putting lot of effort for you to give wonderful results, dear students. Like it, subscribe and stay connected. I am going to give you a beautiful set of results, dear students. Okay. Next, this is all about centroid, guys. Shall we move to the next concept, orthocenter? Orthocenter. Ready? 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 Ready, everyone? All of you ready to learn orthocenter? Fine. Yes, guys, ortho means, do remember in math wherever you get the word ortho, ortho means perpendicular. Ortho is a word related to Greek. It is ortho means perpendicular. It is very simple, guys. Suppose this is triangle ABC. If you want, altitude is something you draw from the vertex perpendicular to opposite side. It is perpendicular, guys. So can I say that BD is equal to DC? Yes or no? BD is equal to DC? Yes or no? Yes or no? BD is equal to DC? Yes or no? Man of the series. Venkateshwar Naidu. Thank you. Thank you very much. Yeah. Can I say BD is equal to DC? In fact, no, bhaiya. Sorry, it is just perpendicular. It doesn't guarantee that BD is equal to DC. If these two sides are equal, then these two will be equal. Otherwise, no. If you want, you can just see this triangle. You just drop a perpendicular. This is perpendicular, bhaiya. Will these two be equal? No. No. These two will not be equal. So this is why, guys, median ensures these two equal, altitude ensures here 90 degrees. Got my point? So please be clear with this. Median is different, altitude is different. Altitude is just something you have drawn perpendicular. Unless there is some special data, we can't ensure BD is equal to DC. Right, everyone? Fine, chalo. Now, if you take triangle ABC, in triangle ABC, okay, now you just drop one altitude, fine, this is AD, another altitude BE, the third altitude will also pass through the same point CF. So in a triangle, all the three altitudes will be concurrent, and the point of concurrence is called orthocenter, denoted by O. In some books it is denoted by H also. Both are valid. Generally O. We go with go. Okay, we go with O. Okay, fine. Now, as far as orthocenter is concerned, one important point, bhaiya, one important point, listen to me. So, that is, if O is the orthocenter of triangle ABC, the orthocenter of triangle OBC will be A. Listen to me. What is orthocenter of triangle OBC? It will be A. Similarly, triangle OCA, it will be B. Triangle OAB, it will be C. This is a very, very important result, guys. Coming to orthocenter. If you want, I'll try to explain here. Listen here. You consider triangle OBC. This is triangle OBC. Okay? OBC. Now, I'd like to draw altitude from B onto OC. You know, dear students, if the triangle is like obtuse angle triangle, how to draw perpendicular from here? We extend here and we drop the perpendicular, right? In the same way, you try to draw perpendicular from B onto OC. That perpendicular is this, because I have extended. Okay? In the same way, you see, from here, how to draw perpendicular from C onto BO? Here also I have extended. So this is the altitude, second altitude. Now O2, this is third altitude. These are the three altitudes, altitude 1, altitude 2, altitude 3, sorry, altitude 3. Yeah. Yeah, this is altitude 3. These three are not concurrent here. You just extend them to be concurrent. If you allow them, they meet, they come out and meet at A. So this is why, dear students, for triangle OBC, orthocenter is A. Once again, what is orthocenter, guys? Orthocenter is the point of concurrence of altitudes, point number 1. So especially in triangle ABC, if O is orthocenter, for triangle OBC, orthocenter is A, triangle AOB, orthocenter is C, triangle AOC, orthocenter is B. Is it clear, everyone? Clear, everyone? Clear? Clear? Fine, chalo. Next. A circumcenter is a beautiful one. Circum means outside. Before we go to circumcenter, guys, try to answer my question. A is a point, B is a point. So AB are 2 points in a plane. AB are 2 points in a plane, right? how many points will be equidistant to A and B? Can you answer? So what are the points which are equidistant to A and B? Come on, tell me. What are the points which are equidistant to A and B? Can somebody say? Yeah, actually midpoint is 1 point. Not only that, you will get many points here, guys. So suppose if you take P here, PA is equal to PB kind of. If you join all such points, you are going to get a perpendicular bisector of this line. Once again, let me repeat. If AB are two fixed points, you see this, if you take the perpendicular bisector is nowhere related to a a triangle. It is related to a line segment. For you see in 6th class you might have drawn, we take compass and take more than half cut here and more than half we cut here. If we join, we'll get. Perpendicular bisector is a line which is perpendicular to this and bisects also. Perpendicular to this and bisects also. One important point is, you take any point on the perpendicular bisector, you will observe AP is equal to PB, because these two are congruent triangles. You take Q here, AQ is equal to QB. This is nothing but set of all points which are equidistant to A and B. Clear? Set of all points which are equidistant to A and B. Chalo. Now dear students, mean to say, you take triangle ABC, bhaiya. You take triangle ABC. Now I'd like to draw perpendicular bisector of BC. Perpendicular bisector of BC, quick, come on. So I have drawn, you see, please observe that perpendicular bisector means at midpoint you are drawing perpendicular. So guys, you see, median is drawn from A, altitude is drawn from A, but this may or may not pass through A. This is not drawn from A generally. It may or may not pass through A. Got the difference, dear students? Median A to midpoint, altitude A to perpendicular. But perpendicular bisector is just drawn at midpoint, perpendicular is drawn. It may or may not pass through A. Got it, everyone? Clear? Fine. Similarly, you just draw perpendicular bisector here and here. So this is the point denoted by S. You see, since it is on perpendicular bisector, SB is equal to SC. Since it is also on this, SA is equal to SC. If you combine, you are going to get SA is equal to SB is equal to SC. Arey yaar, circumcenter is nothing but that point which is equidistant to all the three vertices. For example, in the map you identified three villages. Three villages are there which are suffering from water problem. You are the district collector, you want to give a well or borewell or water facility at one point. You have to choose circumcenter because it is equidistant to all the three villages, correct? Circumcenter is that point which is equidistant to all the three villages, correct? Yeah. So this is the, now you take compass, take this point as center, this distance as radius. You just try to draw a circle. The circle definite, because same distance, no, it will pass through BCA. You see, circle is outside, triangle is inside, so the circle is called circumcircle. Okay, it is called circumcircle. Circum means outside. Okay, the circumradius is generally denoted by capital R. Fine, dear students, circumcenter, right? So far we have discussed about, you see, centroid G, orthocenter O, circumcenter S. Fine, everyone? Clear? Many of you didn't like the video. Like it, subscribe it so that it reaches most of the members. Like the video and subscribe and reaches most of the members. Clear? Right? Now dear students, after circumcenter, yeah, you see this, all of you, this is a triangle, median, median, median. All the three medians are concurrent. The point of concurrence is called centroid, G. Yes. Next, the point of concurrence of, please note it, point of concurrence of medians is called centroid. Next guys, this is a triangle. I have dropped altitude onto this, second altitude, third altitude. All the three altitudes will be concurrent. The point of concurrence is called orthocenter, denoted by O. Okay, right? So point of concurrence of altitudes is called orthocenter. Altitudes is called orthocenter. This is a triangle. This is perpendicular bisector, second, third. The point of concurrence of perpendicular bisectors is denoted by circumcenter. Let it be S, guys. Yes. Now, yes, perpendicular bisectors is nothing but circumcenter. We have discussed. Now, in center, guys, in center is very simple. Listen to me. In center means in triangle ABC, you just drop internal angular bisectors. This is second internal angular bisector. This is third internal angular bisector. All the three internal angular bisectors are concurrent at a point called in center. Actually, angular bisector is that point from which if you drop perpendicular onto these two will be equal by congruency of triangles. So, here this point 2, you just drop perpendicular to all the three sides, they will be equal in distance. So, if you draw a circle, it touches all the three sides. So, this circle is inside, so we call it as in circle. Its center is denoted by I, radius is denoted by small r. Okay. Median and altitude. Somebody is asking difference between median and altitude. Suppose you take a triangle, median means this vertex to midpoint of opposite side, this is median, this vertex to perpendicular to opposite side, this is altitude, this is altitude, this is median, that is the difference. Got it? Okay, right, dear students. So, in a triangle, in center is nothing but, yeah, in center is nothing but the triangle, the point of concurrence of internal angular bisectors. Okay, that is what we have written. Okay guys, internal angular bisectors is called in center. Now, the most important beautiful point in a triangle, guys, a very important point in a triangle, right? Yeah, you see, dear students, in a single triangle, what if we plot orthocenter, circumcenter, centroid at one place? There is a beauty, that is, you see, in the single triangle, I have dropped two altitudes, so this point is going to be orthocenter. Clear? Clear? And in the same triangle, I have drawn the two medians. These are medians, guys. These two are equal, these two are equal. So, this is nothing but centroid, centroid. Okay. Now, perpendicular bisector, two are enough because we know already they are concurrent. This point is called circumcenter. Got it? In the same triangle, I have plotted orthocenter, circumcenter, in center. Now, there is a beauty, dear students. You take any triangle, orthocenter, circumcenter and centroid will be collinear. Collinear. The name of this line is Euler line. Euler line. And moreover, dear students, they will be such a way spaced like centroid always divides the median in the ratio 2:1. Okay. Centroid, not only median, this G divides OS in the ratio 2:1. Please do remember, it is very important. OSG. It will be like this. G divides OS in the ratio 2:1. So that means 2S plus O by 3 is equal to G. So please try to remember this result like O is equal to 3G minus 2S. Please all of you text here. All of you text here, let me see. All of you text here. O is equal to 3G minus 2S. So wonderful result, very important result in a triangle. Yeah, in a triangle, if out of OGS, if two of these three are given, we can find the third. All of you text here. O is equal to 3G minus 2S. Come on, quick. O is equal to 3G minus 2S. Quick. In center is nothing but point of concurrence of internal angular bisectors. I want to see more responses here, guys. I want to see more likes, more subscriptions. O is equal to 3G minus 2S. Quick. Yeah, fine. Good, wonderful. Nice, dear students. Proof takes time. It's a lengthy theorem. We'll discuss some other time. Its proof is also very simple, very easy. And we have a topic called trigonometry, solutions of triangles, where we'll prove all these things. Even we can derive formulae for the distances from the centers to the sides also. So dear students, orthocenter, centroid and circumcenter are always collinear. The line is called Euler line, and G divides OS in the ratio 2:1 always. So O is equal to 3G minus 2S. This is an important takeaway from today's class. Guys, clear? Next, in equilateral triangle, guys, generally students, you see, you take any triangle. Suppose if you take acute angle triangle, all OGS will be inside of the triangle itself. Whereas if you take a right angled triangle, you see guys, this is going to be the orthocenter, midpoint of hypotenuse is the circumcenter, G will be here. Okay. If you take an obtuse angle triangle, orthocenter comes out this side, circumcenter goes out, but centroid will always be inside of the triangle only. Okay. So these three are simple points. So acute angle triangle and right angle triangle, we can say obtuse angle triangle. Now you just see in an equilateral triangle, guys, you see orthocenter, the point is orthocenter, that itself circumcenter, that itself centroid, that itself incenter. So do remember, in an equilateral triangle, all the four special geometric points will coincide. Clear everyone? Clear? Most important, in an equilateral triangle, OGSI, all will coincide, right? Next, yeah, isosceles triangle. Isosceles triangle means suppose these two sides are equal. If this is unequal, generally we call it as base. Isosceles triangle, if these two sides are equal, this is the base. Okay, seems to be all equal, but suppose this is different. Now the median drawn, you see, in this is orthocenter, incenter, centroid, circumcenter. All the 4 points will be collinear on the median onto the base. Okay, in an isosceles triangle, all the 4 points, because this itself median, this itself altitude, so it is perpendicular bisector, even angular bisector also. So obviously the 4 points must be on it. Okay. So dear students, do you understand the Euler line in an isosceles triangle? Chalo next, right angled triangle, guys. It's a very important one. In a right angled triangle, where will be the orthocenter? Orthocenter will be the vertex containing right angle. Very important. In a right angle triangle, where will be the orthocenter? Where will be the orthocenter? It is the vertex containing right angle. Clear? And where will be the circumcenter? It is the midpoint of hypotenuse. Midpoint of hypotenuse. Anyhow, centroid will be that point which divide this in the ratio 2:1. Okay. Please do remember guys, this is very important one in a right angle triangle. Okay. So in center is fine. Before that, try to solve this question, dear students. Try to solve 2, 3, 2, 5, 7, 5. So consider the triangle formed with these three vertices. Find the orthocenter and circumcenter. Come on quick. Shortcut, dear students. Shortcut. But still many students did not like, subscribe. Subscribe here. Subscribe to the channel. Like it. Forward it. Okay. Right. Come on quick. Suppose this is some triangle. What is the orthocenter and circumcenter of this particular triangle formed by these three vertices? Dear students, one important point is here x coordinate is repeated and y coordinate is repeated. If you find any three vertices of this kind guys, if you find any three vertices of this kind where x coordinate repeated, y coordinate repeated, it will form a right angle triangle. It will definitely form a right angle triangle and the right angle will be at this vertex. So you see this will be like this point 2, 5. Obviously this is 2, 3, this is 7, 5. So one can say, dear students, obviously this is orthocenter. Midpoint of these two is the circumcenter. Midpoint of these two is 9/2, 4. This is the circumcenter. Right everyone? Right everyone? Do you understand? The same finding altitude, circumcenter, and we can do after line equations, right? So this is easy, okay, right? Now one more question, dear students, one more question, try to answer. You see root 3, root 10, yeah, this is root 6, root 7, root 2, root 11. These are the vertices of a triangle. These are the vertices of a triangle. Can you find the orthocenter of this triangle? Orthocenter. Orthocenter. Come on quick. This is a important question, beautiful question. Can someone say, dear students? What is the orthocenter of this? Shall I do this question in less than 1 minute? Less than 1 minute? Shall I say this question in less than 1 minute? Shall I? Yes. We are left with only 3 minutes. We shall do. Our observation is all the three vertices are, you just find the distance from each vertex from origin. This is root 13, root 13, root 13. That means all the 3 points are equidistant from origin. So origin is the circumcenter. I want orthocenter. O is equal to 3g minus 2s. 3g is nothing but sum of x coordinate, root 3 plus root 6 plus root 2, root 10 plus root 7 plus root 11. Minus 2s is anyhow 0. This is the orthocenter, right? Clear? So observation is all the three are equidistant from origin. So origin is the circumcenter. So out of 3, centroid is very easy to find. So when you know, yeah, centroid and circumcenter, it's very easy to find orthocenter. Okay. So dear students, we are left with 2 minutes. Before that, let me conclude. Yeah. So with Euler line, important Euler line here. Okay. We shall conclude here. Dear students, triangle is a beautiful figure with infinite wonderful results. Of these today we are talking about the geometric points. The point of concurrence of medians is called centroid, denoted by G. Altitudes is called orthocenter, denoted by O. Perpendicular bisectors is circumcenter S. Internal angular bisectors is incenter I. We observe that in any triangle OGS will be collinear and G divides OS in the ratio 2:1. Important point that we need to remember is O is equal to 3G minus 2S. In an equilateral triangle, all these 4 points will coincide. In an isosceles triangle, all the 4 points will be on the median onto the base. In a right angle triangle, the vertex containing right angle is the orthocenter, midpoint of hypotenuse is the circumcenter. Of course, centroid divides that OS in the ratio 2:1. That's all for the day, dear students. So, all of you, before I conclude, dear students, this is scalene triangle is a general one. They will be in a zigzag way, scalene triangle. No special result, but OGS will be collinear. That's all. So, dear students, those who like this session, like it, subscribe to Sri Chaitanya channel and forward it to your friends. And dear students, catch it tomorrow with a new topic. Maybe straight lines related concept will be introduced tomorrow. That's all for the day. Thank you. See you. Bye. Take care.